All right, so now we're looking at the interquartile range. The interquartile range is the range of the central half of the data. So we look right to the middle. We want half of the data, but centered on the middle. To calculate the interquartile range, you must locate the first quartile and the third quartile. Determine the interquartile range for Janet's golf scores. So let's just take a look up at our little graph here. If I come back and talk about, this is my median, half of my data, interquartile range. This is it here. This is our arrow. This is half of my data. So the range is going to be from my Q3, subtract my Q1. That's going to be my interquartile range. So I simply say this is Q3, subtract Q1, which from our values, Q3 had a value of 104.5, right? This is 104.5. Our Q1 was 95. So our interquartile range is 9.5 strokes. Therefore, the central half of her golf scores has a spread of 9.5 and is from 95 swings to 104.5 strokes. That is the interquartile range. Now what we can do is all this data that we've collected, we can use to graph something that's known as the box and whiskers plot. It's supposed to look like a box that has whiskers. So this plot of the data illustrates the interquartile range, so we're going to use that data we just calculated, and the median. The box shows the first quartile, the median, and the third quartile. Well, of course, if the interquartile range, in order to calculate that, that is the third quartile minus the first quartile, so that data is going to be shown. And then the ends of the whiskers represent the lowest and highest values in the set of data. Thus, the length of the box shows the interquartile range. Let's see what that means. So we're told that the lowest and the highest values in the set of data, we need to plot those. So our lowest data point was an 88, and our highest data point is 110. 88 to 110. So what I do is I come in here. This is 85, 86, 87, 88. So I'm going to put a dot at my 88, and I'm going to come up to 110. Don't worry about how high. It's an arbitrary value. We're not. Notice that there's no axis down here that has no value. So I've just plotted my lowest and my highest points. Then I also need to plot my quartile 1, which had a value, Q1 had a value of 95, and Q3 had 104.5. So 95 and 104.5. And then finally, we also want to know what median value was, which is quartile 2. Quartile 2 is measured to be 98. This is our 98. Now what we do is we draw the whiskers. The whiskers go from the lowest value to quartile 1, the highest value to quartile 3. We now draw a box around Q1 and Q3, and we draw a line through our Q2. So our data points, this is our lowest datum, our highest datum, our Q1, quartile 1, our Q3, our quartile 3, and our Q2, or median. And this is a way that statisticians like to represent data. It shows where the majority of the data, the middle 50%, where that's located. This is the box, represents 50% of the data points, and it's not centered around, but 50% of the data points around our median value. So we can see that a significant number seem to have greater than our median that are contained within the 50%. As you look and study more and more stats, those various figures will have more meaning for you. Right now, we need to know how to be able to create these graphs. And now finally, we're going to look at percentiles. So what we just did here with quartiles is we took all of our data and we spread it up into 4 even groups of data points. The concept with percentiles is we'd be doing the same thing, but instead of dividing it into 4 equal parts, we'd be dividing it up into 100 parts. Percent, the word cent in French, cent is 100, so it's per 100. So we're comparing our data as though it were equally distributed in 100 even points. So that's what we need to do. So for example, the 99th percentile would represent the datum that exceeds 99% of the data. So quartile 3 represents the data point that's more than 75% of our data. Quartile 2, the data point at our median, represents the data that exceeds 50%. 99% of the data would be the 99th percentile. The 47th percentile is the datum that exceeds 40% of the data. So how do we do that? Find the 95th percentile for Janet's golf scores. So that's how would we go about finding it. We know that the number of data points that we have are 20. And so we want to find out what 95% of 20 is. 95% of 20 is 19. So we look to find out what her 19th score was. Her 19th highest score, I come back to my data table. I find my cumulative frequency, 18. My 19th score was at 110. So my 19th score had a swing of 110. So 110 is the 95th percentile of her golf scores. Some questions for you to work on are located here. If you've got questions, please come see me. Remember, I'm always available at lunch, or almost always, and often after school. So just come and set up an appointment to see me.